I wanted to show you a quick example of a function whose left and right horizontal asymptotes have different values. To get there, I want to make an observation that you may have noticed before, and that is that when we consider the absolute value of x as a function, then there are a couple of ways that we could think about it. One way is that we could take the number that we are finding the absolute value of and square it, and then take the square root of that number. So if we have, for example, the absolute value of 3, then that would be the square root of 3 squared, which is the square root of 9, which is 3. On the other hand, the absolute value of negative 3 would be the square root of negative 3 squared, which is the square root of 9, which is again 3, the absolute value of negative 3. There's something else that I want you to observe, and that is that the absolute value of x is a number that is guaranteed to be non-negative. And the way that we fulfill that guarantee is that when x is already non-negative, we leave alone. So the absolute value of x is simply x for x's that are greater than or equal to 0. But when x is negative, the absolute value of x is the opposite of x. Notice this carefully, that the absolute value of x is going to be the opposite of a negative number, which gives me a positive number. Now, with that said, what I'd like to do is to take a look at this interesting function. F of x equals x over the square root of x squared plus 1. And I'd like to ask this question. What are the horizontal asymptotes of the graph of F? And we remember from our class that y equals L is a horizontal asymptote of the graph if and only if either the limit as x goes to infinity of f of x is equal to L, or the limit as x goes to negative infinity of f of x is equal to L. And so the limits at infinity are going to be the tools for finding the horizontal asymptotes. Here we go. We're going to take the limit as x goes to infinity of x over the square root of x squared plus 1. And we immediately notice that the form of this limit is infinity over infinity, or an indeterminate form. And so we want to do a little bit of algebra. And the algebra that we want to do is to divide top and bottom by the highest power of x in the numerator, which is x itself. So I'm going to divide x over x here, and I'm going to divide the square root of x squared plus 1 over x here. Now the top is easy, that's just 1. To simplify the bottom, I'm going to need to write x as something to the 1/2 power. And because x's are very large positive numbers, therefore I can write x as the square root of x squared. Just like that, which now allows me to write root x squared plus 1 over x squared, which in turn simplifies to root 1 plus 1 over x squared. And finally, I can use my theorem that 1 over x squared is going to go to 0 as x goes to infinity. So this gives me positive 1 as the limit as x goes to positive infinity, and I conclude that y equals 1 is a horizontal asymptote of the graph. Well, what about as x goes to negative infinity? We're going to use the same kind of algebra, but when we get to the point of dividing by x, we have to recognize that because x is taking on very large negative values. X is no longer the square root of x squared, which would be positive. Instead, x is the opposite of the square root of x squared. It is a negative number, which then gives me the limit as x goes to infinity. Let's see here. 1 divided by negative 1 is negative 1 over root 1 plus 1 over x squared. And again, this guy goes to 0, so that my limit is now negative 1. And I get that y equals negative 1 is another horizontal asymptote of the graph of f. This was some very interesting analysis, and we wonder if the graph would confirm it. So we pull up our graphing calculators, and we let y equal x over the square root of x squared plus 1. And we let y2 equal 1, which is the equation of the first horizontal asymptote that we had. And we let y3 equal negative 1, which is the equation of the second horizontal asymptote that we had. And we set our window size to a suitable set of values so that we can see the long-term trend, and the y values similarly, and hit graph. And when we do, here comes the curve, f of x. Here comes the line y equals 1, which certainly appears to be a horizontal asymptote. And there goes y equals negative 1, which appears to be a horizontal asymptote as well. I hope this was interesting to you.